Hi, this is Kumaran. In today's video, we will discuss about sorting of an array of numbers. So sorting means you know that we can rearrange the data either in ascending order or descending order. Ascending order means from smallest number to largest number. The vice versa descending order means we will start with the largest number then to ends up with the smallest number. So that's the thing. In 8085 microprocessor assembly language, how to sort a given array of numbers, that's what we are going to discuss in the today's video. Let's move on to this logic behind this. So for example, we have n elements of array available on the 8400 memory address. So always whenever we use array of numbers, the first element always will point out that the count, how many number of elements we have in this. So for this case, we assume that the number of elements are 5. So you can take any, but the first element should point out how many numbers you have. So here in this case we will have any number C8, F2, 15, 9A. Likewise 0 to FF any number you assume. Then here it is 10. So this is the data we assumed. So in this we have to perform the sorting operation in ascending order. Ascending order means the 10 to be on the first element, then 15 second element, then 4A third element, the C8 fifth element, fourth element, and F2 will be the fifth. So in that order it should be sorted out. So already we discussed how to compare and get the smallest or largest in the previous program, searching smallest or largest. The same logic we are going to use. So the first comparison is we are going to compare these two. So between this C8 and F2, which one is smallest? C8 is the smallest. So keep this is in same because already it is in ascending order only. Now the next element F2 and 15, compare these two. So which one is smallest here? Here the smallest is 15. So you take this 15 here, then have that F2 at this point. So we have to compare again. What? F2 with the 4A. So F2 and 4A should be compared. The result between these two, the 4A is the smallest. Now again we have to compare with the F2 with the 10. So F2 with this 10 you compare, the answer should be 10 is the smallest number, then FA will be your largest, that will be on the last element. So now one set of comparison over. Now check whether it is completed or not. No, because 10 is the smallest, that is not yet to reach that first element. Again repeat this process between these two, which one is smallest? 15 is the smallest. You take this 15 here. Now compare that C8 and 4A. 4A will be the smallest, that you take here. Now C8 and 10 you compare. The 10 is the smallest. The next C8 and FA. C8 is the smallest. Then F4 will be, FA will be maintained as FA or F2. Sorry, it is not FA, it is F2. Okay. So now we check whether it is arranged or not. No, till it is not completed. Again you compare the first two elements, 15 and 4A. The smallest on this, it is 15. So then 4A and 10 is the smallest. Then 4A and C8, 4A will be the smallest. Between C8 and F2, C8 will be the smallest. Then here F2. So is it completed now? You check? No. Till that 10 and 15 another comparison needed. So we will complete this to 15 and 10. We will have 10 as the smallest. Then the 15 between 4A, 15 is the smallest. Then remaining are same order. it will be return say 4a c8 then f2. So this is what the ascending order of the given numbers. So let's do this. How many comparisons, how many number of sets we needed? So we need 4 sets of comparison. So each and every set, within the set, how many comparisons we need? So in this case, we have 5 means we need that 4 number of sets. Then within a set, we need 4 comparisons. 1, 2, 3, 4. So if we have n elements, we need 2 counter. One counter is number of sets. Then within a set, one counter is number of comparisons. Both are n minus 1. So that we need to have clarity in this. So this is what the logic behind the sorting of array. So we need to count. One count is how many set of comparisons needed, then how many comparisons within a set needed. So both are n minus 1. So that's what we assume here. So let's start the program for this. See here, when you compare these two, suppose carry occurs, suppose no carry means straight away you go to the next one, because no carry means if carry occurs, we have to go with the next, because whatever the first element is smallest one, so that you keep here. Suppose no carry, F2 and no carry means we have to exchange from 8403 to 8402. So here we have to exchange between these two. So exchange is not possible directly. That's why we are copy this memory data to some other else, then copy this data to here, then from that register to here. Here triangle, for example, here I am going to use the register E means. So this 15 will be taken to E register, then this will be copied here, then E will be copied, this data will be copied to this memory element. So likewise this triangle transfer will happen for exchange, because we don't have instruction directly exchange between memory address in 85 microprocessor. So that's the task involved in this comparison. So let's start the programming here. So the first element is a count that you will use this LDA, the address 8400 will take. So we are taking this count and use this some other register, for example move E register. E register I planned for exchange, so here I am using D register comma A. So this is for number of set. So the number of set is how many? Only 4. So decrement once. Due to n minus 1 comparison, we are decrementing this. DCR D register. So the number of set is initialized with the D register and decrement once. Now we have to go to that within a set how many comparison needed. So in this case we have to use indirect addressing, as we have to handle a string of elements. So use that indirect addressing. For that we will initialize HL pair with the given address LXI H comma 8400. You can ask that already 8400 we have taken it for count as number of set, but within a set also we need the same element only, same count we need. That's why we are initializing again HL pair with the 8400. Take some other register. Here D register I used, then I am going to use that C register, move C comma M. So which means the number of comparisons within a set, that also n minus 1, 4 comparison only. So decrement once, DCR C. Okay. Now we have initialized 2 count and both are decremented once to justify that n minus 1 comparisons. Now we have to go to the first element. So for that use that INX, increment H, copy the data to accumulator, because when you compare we have to have the first element on the accumulator. That's why I am copying it to accumulator now from M. So if you feel the video is slow, you can watch this 1.25 or 1.5 speed. Then you have to point out next one, increment H. Then you compare with the accumulator and M now. Compare M. So now we started the task of ascending order. So ascending order means what? If no carry means, suppose carry means no need of exchange. So that's what we are going to do. So jump on no carry. No carry means already in ascending order only. Jump no carry, go to the next. This is our task. No carry means, let's assume if it is no carry, okay. Suppose carry means whatever here it is smallest. For example, C8 minus F2 carry will occur. So if carry occurs, it is already in ascending order, no need of exchange. Suppose no carry, so the what next we have to write. Whenever we want to write any conditional jump means if condition not satisfied, that only we have to write next. If for example in this comparison F2 minus 1.5, if no carry will occur, in this case what we have to do? We have to exchange this two. So for that, the temporarily the current M will be copied to E register, then from accumulator to memory, then E register to memory, which is decremented once. So let's start this move E comma M. We'll take the current element E as a mediator. You decrement once the memory to point out DCX H. Take the current element. Current element is available on accumulator. So you copy that, move M comma A. Here one more correction. I use that eraser. Yeah. We have taken that E as a copy, then we have to copy this A to M. So now we have to decrement, because the current element current element is this one, whatever accumulator is having, that to be written here. So F2 I am copying to 15 is copied to E register, F2 is copied to current M. Now decrement once DCX H, then copy from the buffer is E here, we copy, move M comma E. So now increment once to justify that the current element, increment H. So this is what we have to do if no carry. No carry means we have to exchange this. For exchange this much steps. We are taking the current value to buffer, copying from the previous value to current memory, decrementing the memory once, copying the buffer value to memory. Again we are incrementing to point out. Now this memory will point out 8403. So this is. So now it's over. Now we have to decrement the count within a loop. Within a loop is C. So we'll decrement this DCR C. If no zero, we have to, no zero means within a loop. For that we will use that any label you can use. For example, I am using A1. Okay, the A1 should be here because the current M is pointing that current location, that to be copied. This is A1 within a set. Okay, so here we have used a label jump carry next means, so if carry occurs, straight away you decrement the count. So here we have to use. This video length will be higher because the logic involved in this also bigger, that's why it will take some more time. So the now within a set is completed, so we have to now go to the number of sets. Number of set is D, so again decrement here DCR D, jump no zero. Suppose no zero means here the number of sets we have to go with another label A2. See, if it is no zero means what? The entire process we have to start again. That's what we are doing here, LXI. So here this label should be in this. Okay, so completed now. Jump no zero A2, then alt. So where we will refer the input output in this. See, input output on the same memory address. The count will not be changed, but after completion of the program, the same memory address, the data are rearranged in ascending order. So this is the task in this. Suppose you want to perform the descending order. Descending order means what? Here the logic involved here is C8 and F2. In this case, instead of carry, we have to use jump no carry. That's the only change, because the logic is we have to get the largest number that to be stored here. So instead of JC, we will use that JNC. So that will perform your descending order. So that's what the logic involved and programming of sorting. Let's go back to the simulator and check this. In simulator, we will write the program, and this is the program for sorting in ascending order. As per the logic, you discussed the program. Program is being typed, input also being given. Just to run the program, compile this, no error. Just to run the program, whether it is being arranged in ascending or not, we will check it. So here, see, look at that. One is all the data is being shifted one by one. So the 10 is shifted in this top. So once it is completed all this, the program will stop. Yeah, this program stopped. Now it is in ascending order. The same thing, if you want to descending order, you make this J and C. Again you compile the program and run this. It will do the same thing in reverse direction. F2 will be come first, then C8, 4A. Like you will get the data in descending order. You will perform. So like this you can perform input output, give write the program and get sorted output in the simulation. Okay, thank you.